Alright, hello, this is lesson 4, graphing linear inequalities. In lessons 1, 2, and 3, we worked with coordinate pair, slope, slope-intercept form, and all that's still going to be used in graphing linear inequalities. Now, your understanding of those first 3 lessons and that content really pays off when you move into inequalities, because there's not a whole lot of difference. Let's start out looking at the difference of inequalities and equations, first of all. The main thing when you're working with y equals mx plus b is it's the exact same thing. You're just working with less than, greater than, or less than equal to, greater than equal to symbols rather than an equation. So let's look at a few examples of how these differ. First, what I'm going to do, I'm going to graph these. And we're going to do y equals x minus 1 first. So it'll serve as a review and hopefully highlight the differences of an equation and an inequality. So first off, y equals x minus 1. Your slope in this case, since you don't have a number in front of x, is going to be 1. And a slope of 1 means you go up 1 and right 1 from your y-intercept. So the first thing you want to do is plot your y-intercept of 1. And that's what this negative 1 right here tells you. So it's what creates that dot on the y-axis. So if you go up 1, right 1 from there, it'll be here. Up 1, right another, just like that. 3 dot minimum every time you make a graph. Let's go ahead and connect that up using my line tool. I'm going to go all the way across the graph, make that a nice professional looking line. And it needs an arrow in the end because it does not stop where you show it stopping. So there's your typical graph. You've already done a number of those at this point. Right, now let's look at how that differs from the next inequality, not equation. We're going to look at y equals, or no, y is less than, excuse me, y is less than x minus 1 now as compared to y equals x minus 1. You're still going to start out the same way. You're going to put that negative 1 in there, just like we did in the last example. And your slope is still 1. It's still 1 over 1, meaning up 1 over 1, up 1 over 1. The main difference you're going to look at is because of this symbol. Y is less than. Now, take a look. Dotted or dashed lines are what are indicated when you're talking about a less than or a greater than symbol. So when I turn my line tool on here, it's not going to work the way I want it to. I want to make sure that I'm getting a dashed line. Let's see if I can line this up. Here's what you're looking for. I'm going to put my arrows in. I only have an arrow on one side, so I'm going to put an arrow on the other side. The main difference is you're looking at a dashed line, not a solid line, when you have this symbol, or the opposite of that symbol. There is another part to this, and that's going to be shading. This one is going to be shaded underneath. Now, that isn't something I'm covering yet, but you will have shading everywhere underneath this line in this particular instance. I'm going to explain that a whole lot further. I'm just going to roughly shade that in just to show a completed graph, but we'll do shading in a couple examples later. And let's look at the bottom one now. Y is less than or equal to x minus 1. You're still going to start out the exact same way. You're going to start out at minus 1. Your slope is still the same, so you're going to go up 1 over 1. Now when you see this right here, what that means is y can be less than or equal to x minus 1. You need to use a solid line when doing that. So it's going to look just like the equation. It's going to look exactly like when we graphed this one 2 screens back. It's going to be a solid line like this. So let's go ahead and make that happen. And then for shading, just like I said on the last one, I'm going to go ahead and put it in there. But your shading is going to go on underneath this. Just going to quickly get that done just so we're not doing anything too wrong or leaving anything major out. And then we're going to move into how to determine that shading in our next screen. All right. So main thing when you're looking at creating the lines on these, you're going to have a dotted line if you're using those symbols. On these symbols, you're going to use a solid line. And that's really the main difference between an equation and an inequality when it comes to putting the line itself in there. Now the shading part that I have in yellow on this page, let me show you that's done. First off, let's go back to this y is less than x minus 1, example 1 problem here. I'm going to go negative 1. I'm going to go ahead and put this in again. And hopefully the graphing is not a big problem for you at this point, and that goes fairly quickly. All right, once I determine this, and that is not the right line. I needed a dotted line for that. All right, get that dotted line in there. There we go. Now what I want to do is determine shading using test points. This is sort of way one to do this. Anytime you can use a point of origin right here, 0, 0, as a test point to determine shading, that's what you want to use. If I use 0, 0, then this is my x, this is my y. When I rewrite this using these points, excuse me, I'm going to have 0 is less than 0 minus 1. What I'm looking for, is it true or is it false? So if 0 is less than negative 1, then it's true. It's not. This is false. And what that tells me is the side with my test point is my false side. The opposite side of that line is going to be my true side, and I'm going to shade the true side. For instance, let me pick a test point just at complete random out here. Here, we'll call this test point number 2. This is 1, 2, 3, 4. 1, 2, 3. So that is, let's use 4, negative 3, and see if it is indeed true or not. When I put that in there, negative 3 is my y. So that's going to be negative 3 is less than 4 minus 1. Now 4 minus 1 is 3. So if negative 3 is less than 3, we're good. The negative 3 is obviously less than 3. What you're going to find with an inequality, and this is a major difference of inequalities versus equations, is you don't just have the solutions that are on this line. You have every solution to the side of the line. So what I was doing in those previous examples when I was shading is got a little outside the line. That's all right with this. When I was shading this, what I'm doing is I'm representing all the points that make that inequality true. And I can't include any of the points that would make it false. Okay, so try to neaten that up just a little bit there. Try to do your shading pretty nice and neat. And when you do your shading, do it light enough you can erase it in case you do get it backwards. It's very easy to get it backwards. All right. Let's look at example 2. Get rid of this. Now for example 2, what I have to work with, this is not in y equals mx plus b format. I'm going to plot my line exactly like this were an equation. I'm just going to, kind of a thought bubble here. I'm going to pretend that's an equal sign when I graph. So I need to put it into this format in order to get my y-intercept and in order to get my slope. So since what I've got is a negative 2y is less than or equal to 6, I need to get this x out of here. So I have negative 2y less than or equal to negative x plus 6. Now big deal is when I divide by negative 2, there's something that you cannot forget to do. As soon as I do that procedure, on my next step, I need to reverse that inequality symbol because I divided by a negative number. Anytime you multiply or divide by a negative number, you've got to convert your, you got to reverse your inequality symbol. So where it was less than or equal to, now it's going to be y, as those cancel, is greater than or equal to. Now this will be negative 1x divided by negative 2, which becomes 1/2 x, and minus 3, because 6 divided by negative 2 is negative 3. Let's graph this. Negative 3 is your y-intercept, so that goes first. Your slope is 1/2. That means up 1 as your change in y, and right 2 as your change in x. So up 1 over 2, up 1 over 2. My symbol has an equal sign in there, so I'm going to be dealing with a solid line. So let's put this line in. And I'm way off. Let me move that up. Alright, that's close. Put my arrows in. Alright, now I need to determine my shading. I'm going to put 0, 0 in as my test point, because you see it's really clearly on one side of the line. I want to see if this is my true side, which is where I shade, or whether it's my false side, meaning my true side would be over here. So let's put 0, 0 in for x and y as my test point. Now I can do that in my slope-intercept form, or I can do that in my original equation. We can try it both ways. If you put a 0 into this original equation, what you're going to have, instead of x minus 2y is less than or equal to 6, you're going to have 0 minus 0 is less than or equal to 6. 0 is definitely less than or equal to 6. If you decided to work with the y is greater than or equal to half x minus 3, you're going to have 0 is greater than or equal to 0 minus 3, meaning 0 is greater than or equal to negative 3. These are true statements, meaning this is my true side, meaning that's the side that I shade. If this were my false side, then I would shade the opposite side. So hopefully that's kind of making sense. I'll do green this time. So when I shade this, I'm going to shade the side that makes my use them as a test point. It's going to use what is true. All right. So just quickly fill this in. I'm using my tablet, so it's kind of undoes its own color sometimes here. Now again, when you shade, try not to show a bunch of scratchy pencil marks. You want it to be nice and neat. It's almost to the point of being artistic. I'm not going to necessarily grade you on artistic talent here, but I do want it to look fairly decent. And make it light. Don't use the tip of your pencil. Just do a light shading. All right. Next, that's not the only way you can determine shading. So let's look at some other ways of getting that done. If you work with the y equals mx plus b format, which you should be very familiar with at this point, and you put everything in y equals mx plus b format, taking care to turn your inequality symbol around when necessary, you can use the slope-intercept form to determine that. So in example 1, x plus y is greater than or equal to 3. Take x away from both sides. I'm left with y is greater than or equal to negative x plus 3. Now this is going to be a solid line. I'm going to start my graph by plotting my y-intercept of positive 3. My slope is negative 1, meaning down 1, right 1 from the y-intercept. Now, I already said solid line. So let me go ahead and get that in. Move it in place. So now all I have left to determine is my shading. To determine shading, it's actually not very hard at all. Look at this right here. What this says is y is bigger than or equal to this. Negative x plus 3, that's your line. That's this entire thing right here that you just graphed. And this says that y is greater than or equal to that. Well, that y value, where it crosses on the y-axis, it crosses at 3. So, as you all know, that's 0, and that's 1, and that's 2 when you're looking at your points on the y-axis. So where's y bigger than where it crosses? 3. Well, that would be 4 and 5 and 6, 7. So obviously it's bigger as you go up. That's all the information you need to get your shading done. You are going to shade above that line. And you're done. Smooth that out a little bit. That's all there is to it. Now, if you want to use a test point, just to show you on that, we can still use 0, 0. If I put 0, 0 in up here, what I'm going to have is 0 plus 0 is greater than or equal to 3. Well, 0 is not bigger or equal to 3. So this is your false side. So you notice true side has to be on the other side of that line. So using slope-intercept, that has it cleared up for me. Let's look at example number 2. Let's get rid of all this. Example 2, if I put that into slope-intercept form, first thing I want to do is move my 3x off the left side onto the right side. So if negative y is less than negative 3x, I don't want negative y, so let me divide both sides by negative 1. If you remember right, that is what has to happen. Don't forget that or you'll shade the wrong side using this technique. Y is greater than 3x. Now what's missing on here? I don't have a y-intercept. So if you don't have a y-intercept, what that means is that it's going to cross at 0. You have a y-intercept, you just don't need to have it written in. It's 0. So now, y is greater than 3x. Remember, to graph this line, I need to use my slope. My slope is 3. That means 3 over 1. Up 3, right 1. So 1, 2, 3, 1. Let's do a 3-point minimum. Let's get that line drawn in. Now, roughly there. I know I missed a little bit on that one. Alright, now where did I mess up? Here's where I messed up, and I think you'll find yourself doing this. This means that I needed a dotted line, and I just put a solid line up there. Now, if you did that with your pencil, just erase segments. On mine, I'm going to have to delete that off. And let's put a proper line in there. There we go. Alright, now we need to determine shading. Since I caught the fact that I needed to turn that inequality symbol around, I'm still looking for y is greater than the line, which is 3x. Y gets bigger going up. Right? That's plus y's, and these are minus y's. You know that. So if this is 0, y, that's 1y, 2y, 3y, 5y, 7y, and so forth. So when I shade, I know I'm going to shade going above the line. So it'll be all of this. Roughly throw that in here. Alright, now, on one thing I didn't talk about on test points is what happens if you can't use 0, 0 as a test point. Well, in this case, since the line is going through 0, 0, I can't use 0, 0 as a test point. So let's use some other point that is obviously on one side of the line. Go ahead and use blue on this one. So let's say I want to use 1, 2, 3, 4, 5, 0 as a test point. Now I want to go back to the x. Where are we here? I can either do 3x minus y is less than 0, the original equation, or I can do the y is greater than 3x, which is slope-intercept form of the same equation. So put a 5 in for x, I'm going to get 15, minus y is 0, is less than 0. That's false. Just put it down here in my transformed version. 0 is greater than 3 times 5, which is 15. It's false, no matter what I use. So this is my false side, so you're going to shade the true side. So we did that correctly. So you don't have to use 0, 0 as test point. It's just easier to do typically based on the equation. Right, so that's how you use slope-intercept form to determine shading. Since this is y is greater than, you're going to shade up. And if it was y is less than, then you're looking at where y gets smaller. Let's see, I think we have the same thing twice, so move on. All right, now you also have same instance that you had with equations is horizontal and vertical inequalities. So let's look at x is less than negative 2. You don't have a lot of options when it comes to this. Remember, you want to graph this just like, let me do my little thought bubble here, just like it's x equals negative 2. Now here's your y-axis and here's your x-axis. So if x is negative 2, that means x is negative 2 regardless of what y's you put in there. So I could put 0, I could put 4, I could put negative 4. So negative 2, 0, negative 2, 4, negative 2, negative 4. That's going to be a vertical line up and down. Now keep in mind that needs to be a checkered line, a dotted line. So make sure I do that correctly. So there's your line. Now how do you shade on this? Now x is less than negative 2. So you have to think, what's less than negative 2? Well, this would be negative 1, x of 0, and x of 2, and x of 4. Negative 2, this would be negative 4, negative 6. Well, my x's are going to be less to the left, and that's exactly where you're going to shade. You're going to shade left of the line that you drew. Right, because that's where all your x's are going to be smaller than negative 2, which is what you're being asked to graph. Right, so this is the part that tells you that. Let's look at example 2. Y is greater than 6. Now, same thing. I've got a y-axis. Oh, that's not what I needed. I've got a y-axis here, and I need y bigger than 6. Again, I'm going to thought bubble that thing as y equals 6 when I'm graphing. And if I want to just get myself centered, I know y is going to be 6 regardless of x. If x is 0, y is 6. If x is 2, y is 6. If x is negative 2, y is 6. So let me graph that. 2, 4, 6. And that is going to give me a line that goes back and forth. It's going to give me a checkered line back and forth. A dotted line. Just like that. Alright, so where is y greater than 6? Let's go back and look at our sign here. Y is greater than 6 as you move on up past this line from 0, 0, 2, 4, 6, 8, 10. So where you're going to shade is above the line. So as long as you understand how to plot horizontal and vertical lines in a way of equations, then the actual figuring out what should be shaded, that's going to seem like the easy part to you. All right. Well, that's really about all there is to it. I think we're at the end here. So that's the end of graphing. The next thing we're going to be working on is solving systems of equations. So we're going to get a little bit of graphing in there, but for the most part we'll be working with something called the substitution method and another method called the elimination method for systems of equations, working with more than one equation at a time. All right, so that's it for lesson 4. For algebra A, that's it for chapter 3. Systems of equations will be our focus for the whole of chapter 4. For algebra 1, you're almost done. Do one more lesson, and that should give you a good basis for your end of course exam.